So we're going to have a look at the tool handle tutorial. This is available on the module site and you can work through the PDF. This video will just guide you through the content of the PDF. So this is the part that we're hoping to create during the course of this tutorial. And this is essentially a typical injection molded handle that you might find on any number of hand tools. So this is the finished article in the window here, and the first thing that we're going to do is kind of mark out the maximum extents of the handle in length and breadth and height, so that when we come to create some of the spline shapes or some of the complicated surfaces of the handle, we can use this shape, this box that we're going to make, as a reference, so that we can be sure that we're modelling it within the right boundary sizes. So this is what we're going to create initially, just a simple rectangular sketch on the top plane. So let's do that now. So I'm just going to take that PDF onto my other screen just so that I can keep making reference to it and just see what the next step is. So this is a 52 by 170 rectangle joined to the origin, as we can see, just on a single corner. So I don't need to OK that sketch. I could accept that sketch, I could OK it, but I'm just going to jump straight into the surfaces tab and then extrude it as a surface. And I believe this is going to be 30 millimeters, and in this instance it might be useful if I cap the end of this extrude, so we'll cap end as well, like that. So we've extruded it as a surface, which means that is just a hollow five-sided box now. And because that kind of marks out the maximum extents or the maximum limits of our part by definition will be inside that box. It won't be any bigger than the box. In some areas it will touch the inside of the box. In other areas it will be slightly smaller than the maximum extents of the box. But in all those instances it would be more useful to make the box transparent or semi-transparent. So that's what I'm doing here. I'm putting the display plane or display pane on. I'm finding that surface body inside surface bodies, and I'm just clicking here to make that semi-transparent. That will be more useful for our purposes. Now what I'm going to sketch the perimeter shape of my finished handle on the top plane. So let's do that now. And this is going to be a mixture of straight lines and two different types of spline sketch tools. So what I'm going to do is put the straight lines in first. So I'm putting a line here, and I'll put another one over here. You can see I'm accepting some of the relations that the system's offering to insert for me here. I've put some coincident relations on certain endpoints here, and I'm going to put some angular dimensions on this line at this end of the shape, and a overall length of that line as well. So we'll have that as 40. So the position and kind of scale of this line on this end, the left hand side, it's fully defined. The one on this side, I'm going to partially define it for the time being, but my intention there is to come back in further on through the design process and fully define that particular line. So you can see it's free to move up and down to a certain degree, and it's free to change its angle as well. And that'll be quite useful, because as we create our surfaced part, using these complex curved surfaces, it can be useful to be able to edit the sketches in real time, so drag the sketch points around and see what effect that has on the finished surface. So those are my two lines. Then I'm going to put a spline between the top two edges of those two lines. So spline tool, top of one line, somewhere in the sort of midpoint of the box here, and then end of that line. And then I'm going to press escape. So I'm pressing escape there. And then with these splines, you can edit the influence of any one particular point along the spline, but in order to do that you have to make the spline edit handles visible. And in order to do that, we just have to click on the spline once, the handles become visible, and then in order to make them stay visible when I click off the spline, like I just did there, you just have to drag and edit their position slightly. So as soon as you've edited their position at all, when you next click off the spline, they will remain visible, as we can see here. And again, I'm going to leave these largely underdefined so that I have the luxury of being able to see them within the finished part and then drag their points around to have an effect on the finished part. But I am going to moderately constrain the shape of this spline, and what I'm going to do is I'm going to put a smart dimension between the edge of the box and that midpoint on the spline. And really all that I'm looking to say here is that midpoint stays within the limit box by a very small amount. So I just don't want it going over the edge of the limit box. So with that in mind, I'm going to limit it to 0.1 millimeters. So it will stay on this side of the line. And then I'm going to press escape because I don't need the smart dimension tool. I'm going to click on the spline so I can see the drag handles again. Here they are for this particular point. I'm going to click on the diamond here, which is the angle that this point influences the rest of the spline, and then I'm going to lock that to be horizontal. So as the spline passes through this point, which is itself 0.1 of a millimeter inside the box, the spline will be horizontal. And in this way we can almost guarantee that this point on the spline will be the highest point relative to the two other ends. So that's quite useful. It gives us a fairly reliable means of ensuring that the spline doesn't go outside of the box on its midpoint. So that's our first spline. Our second spline is going to be a slightly different type of spline. So it's in the drop down menu and it's a style spline. And all I want to do here, I'm going to click on one end of this line, and I want to draw up approximately 10 spline points as I move my way over towards the other line. So that was my first point. 2, 3, 4, 5, 6, 7, 8, 9, 10. And then I press escape to cancel dropping any more points. And then before I edit this spline, I just want to appreciate the differences between how we work with this type of spline and the original type up at the top. So the original type has these drag handles. They affect the quantity of influence of that particular spline point, and they affect its angle as well. Whereas the style spline is surrounded itself by this kind of cage work of points, and it's dragging those points that actually affects the shape of this spline. So in a moment we're going to see quite a dramatic change in this spline. By default, these style splines are set to be highly smoothed. So even though I'm dragging these points into kind of a quite vicious kind of sawtooth shape. This spline itself is not really being hugely affected, but we can change that. We can reduce the amount of smoothing that the spline is set with. So if we click on the spline itself and go over here to curve type and change this from Bezier to a B-spline 3 degree, and you can see there the difference that has made. So what I'm looking to create here is the sort of shape that would fit into 4 fingers of a hand quite easily. So this is a handle, so there's 1 finger, 2 finger, 3 finger. I think maybe we could add another point in here, so I'm gonna click somewhere on the control line where I want to point, right click, we'll try that again, right click, insert control vertex. Where do I want to insert it? There. So now if I press escape and then drag that around, yep, that's having some effect. So maybe put a final little indent there. And then you can play around with these, but again we're going to leave this kind of largely underdefined at this point, with the intention that we come back in and fully define this when we're happy with the finished design. So here we go. Something like that is fine. And then maybe what I'll do, just because it makes more sense to what we're trying to achieve, I might click on this length of the control polygon there, hold down control, click on that end piece and make them 90 degrees to each other, or perpendicular, like that. That sort of puts a little bit more control, and maybe I'll do the same at this end as well. So the spline kind of exits that edge at 90 degrees to the edge. So that looks okay. We want a general kind of curve to this handle, and then we, as I say, we want these indent shapes for our finger points. So then I'm going to accept this sketch. So click on the button to accept the sketch. Now I'm going to click off the sketch to deselect it so that I can see its true colour, which is this kind of grey colour, the same as all sketches. And then, just to make my job easier later on, I'm going to change the colour of this sketch to something bright that actually stands out in the model. So I'm going to right click on the sketch, go down to sketch colour, and maybe have kind of a green colour like that, just so that it's a little bit easier to see. Then what I want to do is create some cross-section or profile shapes down at this end of my handle and at this end of my handle. But in order to do that, I need to put some planes in that pass through the ends of my handle, so that pass through this edge or this line and pass through this line. So reference geometry, plane, click on the line that we want to reference, and then we need a second reference, and we're just going to use the top plane, and then click on OK, and then deselect that plane because we have that still selected. So click in some empty space and make another plane. This time reference this end and then the top plane, and then OK. So we have 2 extra planes there, one that's coincident with this line here and one that's coincident with this line, so that we can now sketch our profile or cross-section shapes for our handle. So I'll sketch on this one first. Depending on how you've set your part up, you may be looking from what we consider behind the line, or you may be looking from this side, from in front of the line. It doesn't really matter, because in this case we're going to sketch at kind of a 3D angle like I'm looking at on the screen now. So I'm going to get the spline tool again. I'm going to sketch in a sort of curved shape like this, 3 points, and then what I want to do is I want to lock the end of this new spline onto the kind of spline itself from the other sketch. So I'm holding down Control and clicking, and the relation that I want to put between these two is make pierce, or the pierce relation, like that. And then I'm going to do the same thing over here. So this point, and hold down Control, and that spline, and pierce, like that. And then with this top point of this sketch, I'm just going to lock that onto the top of my limit box. So make coincident, like that. And then maybe lock these angles to horizontal again. And then if I view this normal to the sketch plane, so normal to, like that, that's kind of what I'm creating. Oh. Now this is one of the things that can happen with splines. As you drag them, when they're under constraint, strange things can start happening like this. But there's always the undo key. If you drag something and you didn't mean to, you can always press the undo key. So because this is intended for injection molding, what I'm going to do is put a 2-degree draft angle on these spline handles here. So you can see I'm dimensioning to the little diamond shapes. I'll set this at 88 degrees. That equates to a 2-degree draft angle. And that will just make it a little bit easier to remove from the mould. And again, we're leaving this somewhat underdefined with the intention that we will actually come back in later and maybe, well, definitely define these shapes properly, fully define them. So I'm happy with that shape, so I'll accept. So now that we've created that first profile sketch, let's create another similar one on this plane down at this end. So I'll rotate my view again so that I can see more clearly. I'll get my spline tool, try that again, create my 3-pointed spline and then press escape. And then I want to use the pierce relation again, so make pierce. So I'm going to select the point, hold down Control, select the spline which is inside the other sketch, and make the spline pierce the point in 3D space. So this only works really, this pierce option, if you've positioned your sketch plane correctly relative to the original sketch. So we positioned this sketch plane so that it was essentially coincident to the end of this spline and the end of this spline, which is actually happens to be what this straight line is kind of tracing a path between the two ends of those two splines. So had we not done that, the pierce command possibly wouldn't have worked. It would depend where we had placed the actual plane. So it doesn't always work, it depends on the actual setup of where you've placed your planes. So now we're going to edit the top point here. I think on this end we'll make it indented from the top of our size limit box. I think we'll set this at 5mm, like that. And then I'm going to click on the spline, and I'm just going to quickly drag the spline control handles or the spline drag handles around a bit. What that does is it means that when I click off them, they will remain visible, whereas their initial state when you create the spline is that they are greyed out, and when you click off the spline they disappear altogether. So you just need to put some movement into them, any movement at all, and then from that point on they will always be visible. So now I'm going to get my Smart Dimension tool. I'm going to put some draft angles on this, so 88 degrees, which equates to a 2-degree draft angle, and the same over here. If you end up dimensioning to the outside of this angle, which I suppose I could do now just for reference, then that would equate to a 92-degree angle, because obviously we are coming at it from the other side there. So these two are essentially doing the same job. And then just before I exit the sketch, I don't need the Smart Dimension tool, so I've exited that. I'm going to lock these angular portions of this adjustment handle to be always horizontal over here. So lock them to be always horizontal. That way this point more often than not will describe the highest point of this profile if we lock it to horizontal. It won't always be the case, but it's a nice way of making that more likely that this point will be the highest point of this spline. So then I'm happy with that spline. Again, just like the other spline that we were working on, we're not locking them down, we're not fully defining them at this point in the process, but we fully intend to come back in before the part design is finished and fully define these sketches. So it's just not to our advantage to do that right now. So then I might rotate my view around a little bit just to appreciate what I've created, and then I think I'll make these two sketches. So I'm clicking on one sketch and clicking on the other whilst holding the control key, and then right clicking, and I want to change the sketch color of these two sketches. So this is just again for my benefit, just so that I can see these sketches a bit more easily. And then I exit the color editing menu there. So at this point I'm ready to create my lofted surface. One thing I will do before I begin the lofted surface is I want to hide the limit box that we created, that was the outer limits of our actual part design. So I don't have a need to see that anymore. I don't want to delete it because it's doing certain jobs. It's holding parts of other sketches in place. So if I want to just hide that, I know that it's a surface body, so I'll find it in the surface bodies folder, and if I click on the icon in this column, it will disappear. So this display pane is quite useful for those sorts of things, showing things, making them transparent, making their appearance slightly different to what it is currently. It's quite useful to have these columns visible. So now I'm going to create my surface loft. So I'm going to go into the Surfaces tab. Lofted surface is what I want, and initially I'm just going to select the two end shapes. So I've clicked on the first one there, it's been entered into my profiles entry box. I'm going to click on the second one, and then in my case I don't get a preview. Now that might be specific to me. You might be seeing a yellow transparent preview on your screen. The problem that I'm having is that these little green dots indicate what the system is trying to do in terms of what point on this sketch it's trying to map or translate to what point on this sketch. And mine is twisted, so I have to click on this green point and drag it across to the other side of my sketch. And then it's trying to map like to like now. So the right hand sides of these two shapes are kind of trying to map to each other, and the left hand sides are as well. But if yours wasn't previewing, it may be because that's twisted, so just click on it and it will flip to the other side. So at that point I'm going to accept that loft just to see what it looks like in its current state. It's very smooth. The default kind of behavior for the loft, and this applies for the lofted feature as well as the lofted surface, is that it just gets from sketch A, or the first sketch, to sketch B in the most direct fashion that it can. So when we look at the edge there, it's just a straight line between the shape that it began on and the shape that it ended on. Now for our purposes, what we'd like to do is we'd like to be able to shape that edge in some way, and we already have a curve that's inside that sketch there that would do the job of describing the shape of that edge. So in order to add that in, that's referred to as a guide curve within the loft. So if we go back into the loft feature, go edit feature, and then we want to put some of these curves into this box here, into the guide curves box. So I'm going to click on the box to activate it, And then I'm going to right click in there and click on Selection Manager. Now the reason we do that step is that we don't want to select the entirety of that sketch that has this wavy line in it. We want to just select a certain line within that sketch. So we don't want the entire sketch, we just want the ability to select a certain line from within that sketch, and that's what the Selection Manager allows us to do. So right click in there, tell it that you want the Selection Manager. This window is the Selection Manager essentially, and we're using this option, Select Group. What that allows us to do is it allows us to select a single edge, as we're going to do, but if we need to, we can select multiple edges from a sketch. So it's quite flexible. So I'm going to click on the edge that I want, and then I want to accept that, so I could move to click on the green arrow, or I could just click on my right hand mouse button. That is what that mouse icon is telling me. If you're happy, click on the right hand mouse button. So I'll do that. And then we can see the effect that that's had on our loft. So the entire loft now has that kind of wavy feel to it. So we're going to repeat that process, but we're going to add this smooth curve to the top edge, or to this edge of the loft. Currently it's kind of taking on the waviness of that edge, and we've got a wavy surface on, or a wavy edge on this side of the loft. But if we right click in the Guide Curves box again, say Selection Manager, and then this time pick the smoother spline shape, and then right click, then we have control over this edge of the loft as well. So we have a kind of wavy, bumpy surface on this side and a smoother surface on this side, both of them being controlled by lines that are in that sketch that we made. So before we exit the loft feature, it's worth probably looking at a few of the options. I'll hide the planes just temporarily because they're kind of obscuring what we're looking at. And the option down at the bottom of the loft menu, which is Curvature Display, if you switch the mesh display on and pull the slider all the way up to the top, it allows you to more fully appreciate the shape that we have created there. So this is essentially the grid work or the mesh that is making up the loft itself. So you can see that this side is largely smooth, and then it gradually transitions over the top of the kind of arch to this more kind of wavy shape down here. So that can be quite useful just to show you exactly what the shape is that you're going to create. So I'm happy with that, so I'll click on OK. Now when we get to that point in the process, the next major step that we need in order to create this this part is that we need to turn this surface into a solid feature. Now it'll still be a solid feature with a relatively thin wall. I think in our case we're going to use a 1.6mm wall thickness. But at the moment it is still a surface and it has 0mm thickness to it. It is a zero thickness surface, so we can't use it directly to manufacture anything. It cannot exist in the real world. It's a purely a tool within the CAD system in order to get us eventually to a solid part that we can then manufacture. So the next three steps allow us to get to that point, and some of these steps may not immediately make sense, but what I'm going to do, I'm going to run through the three steps as the PDF shows you how to, and then I'm going to reverse some of them and talk about the reasons that we performed those three steps and why we didn't do them a slightly different way. So the first thing that I'm going to do, I'm going to mirror this entire shape about the top plane. So I'm essentially going to create the shape or the possible shape of what the entire handle would look like. So say we injection molded this half of the handle design, and then we had a mirror image as the other half, and we injection molded that separately, and then we'd somehow mechanically join them together, either with some kind of adhesive method or welding method or mechanical fixing. That would be the typical way that you would join two halves of handle like this together. So we're going to use the mirror command. The mirror command is in the Features tab, so the Features Command Manager. There's the mirror command. I already had the top plane selected there, but if I didn't, I could have just clicked on it and it would have been placed in the mirror face. The body that I want to mirror in this case is a surface body, so we saw that earlier on. So the body, so I select body there, click on the surface body that I want to mirror. I then get a preview of where the edges will be in the mirrored copy. It looks okay, but there's one final option that we want to tick, which is knit surfaces. So what this does is it unifies or knits together the original surface with the mirror as well. So they form a single surface body. So that's what the knit option does, and we need that option ticked. So we can see now, if we click on mirror in the surface bodies folder, the entire thing highlights. So that is regarded as one unified surface, which if we unticked that knit option, it would still be regarded as two separate entities, two separate surface bodies. So that's why we ticked that. And that helps us, or it's essential to this next step. So I'm going to go back into the surfaces tab, and I'm going to thicken this entire body now, this entire surface body. I'm going to click on thicken. What do I want to thicken? What surface do I want to thicken? Well, I can click on any piece of this entire surface now, so click down there. How thick do I want to make it? In this case it's going to be 1.6 millimeters. And then the last option that you have to consider is what side of the original surface, on the inside or outside or both sides, do you want to add this thickness to? So we've got ours set to go inwards as we're looking at the part. If we tick this middle option, it goes on the mid plane, so our original surface is kind of midway through the finished part. And then if we tick this option, it goes outwards. So you want yours to appear inwards like this, so whichever one of these two buttons you have to press to achieve that preview, where the yellow preview surface has gone inwards, that is the one that you want. So we'll tick on OK, and then you can see it's been given a 1.6 mil wall thickness now, and we don't have it as a surface body anymore. The only surface body that we have in this part is that original extruded box, so we can show that if we just want to check. There it is, the original extruded box that we made and then we hid from view. But what has actually appeared is the solid bodies folder. So if we have a look in there, yes, we actually have some solid material now. So if we wanted to manufacture this in some way, we could do. Injection molding wouldn't be suitable because generally we can only do one half of a shape such as this using injection molding. So what do I want to do now? I want to cut this shape back to be half our design again. So the mirror command kind of created a shape that was the whole design or the whole assembly, and I now want to cut this back so that it's suitable for injection molding. So I'm going to do that with the cut with surface option, and all we have to select is which surface we want to use to do the cut with, and all the planes are just regarded as surfaces, so we can use the planes as a cutting tool, and in this case I'm going to use the top plane. And then the only other option in here that I have to be aware of is which side of the top plane is going to be cut away. So in this case I want to cut downwards. Everything down below the top plane will be cut away. So I've made sure that that arrowhead is pointing in the right direction. And that is what I end up with. So that is essentially the entire shape of our injection moulded part. What I did say was the last three steps, which if you remember were the mirror and then the thicken and then the surface cut. So there's a fair argument to say that the mirror and the surface cut weren't needed, because the mirror created the hole and then the surface cut it back again to be a half. Why did we do that? Well, if I just drag the rollback bar back to a time before the mirror, so now the mirror hasn't happened yet and the thicken hasn't happened yet and the surface cut hasn't happened yet. Let's try doing some of the same operations, but we'll get rid of the mirror. Let's try just thickening now. So we'll put the thicken command on. What do we want to thicken? This part. And in this case I'm going to go a little bit thicker here because it illustrates the point of what we're trying to illustrate more clearly. So I'm going to go up in thickness. Maybe we'll go far beyond what we were originally setting it as. Maybe we'll go 10 millimeters of wall thickness, because it will make what we're talking about easier to appreciate. So there's my 10 mil wall, and then what I'm going to do, I'm going to click on this end plane. In fact, I'm going to click on the right plane, and I'm going to say I want to view normal to this plane, or at 90 degrees to this plane. And what we can see is, even though our part should be ending at the top plane there, so the top plane is highlighted in orange, it's actually hanging down into the kind of negative side of the plane. So there's areas of our part now which have gone outside of our original box shape. So if you remember back to the limits of our part, that box extrude that we created back at the start, there it is. The intention for our part was that it would be no more than 30 millimeters tall. And now, because of this effect that we're seeing when we apply the thicken command, it's actually ended up taller than 30 millimeters. So that's a problem. Now, why is that happening? It's kind of a symptom, or one of the things that's causing it is that we've put a 2-degree draft angle inwards. So when the thicken command applies the thicken, takes that 2-degree inwards lean, and it also applies a 2 degrees downwards lean. So this is essentially a symptom of the draft angle, and we need the draft angle in order to make this part easily removable from the mould. So in order to avoid this problem, one of the methods that we can employ, so I'll get rid of that extra thicken feature. One of the methods that we can employ is we can first mirror the surface like we did. So let me just hide that box. So we first mirror the surface exactly like we did. We make sure that we've ticked the knit command, so it knits that half surface and its mirror image into one single surface. Then when we thicken, we get kind of a 1.6 millimeter offset in this instance inwards from that entire surface. And then when we use the top plane to cut back, or to cut with surface, we can ensure that we have a perfectly flat bottom face to our finished part. So you can see there, doesn't matter how much I zoom in, none of this part hangs below that plane. And that is why we do it that way. It seems as if we're reversing something there. It seems as if the mirror command is working against the surface cut, but it's to correct that little tendency that we were seeing there of the thicken to add material down below the center plane of our finished assembly. So that's why we would do that. So now what we'll do is we'll add some rib features to the inside of this part. So I've rotated my view round. I think I'll make the ribs not quite come up to the top edge of the part. So I think I'll create a new plane to sketch the rib sketch on. So I'm going to use the top plane as a reference. I'm going to create a new plane just like we did before, but this time I'm just going to create it with a 2 mil offset from the top plane. and you can see the direction that that offset is in. It's kind of down into the cavity of my part. So if yours is up above in this direction, you need to click on the flip offset button so that it's down inside the part, like that. Then I want to create a sketch on that plane, so I'll click on the plane, click on sketch. Now what has happened there is the camera has rotated round to view the plane normal to the plane. So this is essentially looking at the plane from the positive side of the plane, and I'm now viewing the part from the outer surface, and that is not what I want. I want to view it from the inner surface. So what I'm going to do, I'm going to temporarily quit out of this sketch that I've just begun. So click on the X. Do I want to discard the sketch? Yes, I do. What I must do is flip the normal direction of that new plane. So I can select the plane there it is, and that icon there will flip the normal of the plane. So it will swap the positive side of the plane and the negative side of the plane. So click, and then I can begin my sketch on that plane. So click on the plane, sketch. Now I'm viewing the part from the inside of the moulding. So then I'm going to create a sketch here. So I'm going to sketch from this edge inwards slightly, like that. I'm going to set the length of this line to be 20 millimeters, like that. I'm going to set a distance from, so I might temporarily hide the planes now because they're making it difficult for me to click on points within the part. So I want to go from this point to this point, and I want to go aligned like that. So I'll maybe set this to 10 millimeters. I'll just check that on the PDF. 9 millimeters, like that. And then the last little bit of constraining that I'm going to do to this sketch is I'm going to put a relation in between the line and this edge, and I want to make them perpendicular. So I want the line to come out of the edge at 90 degrees essentially, and that will do. That's fine for my purposes. So you could accept this sketch, or you could just go straight into the features tab, find the rib command and click on it, and it will accept this sketch as input into the rib command. So the thickness of these ribs I'm going to set thinner than the outer wall, so I'm going to set them at 0.8 millimeters. And then I'm still not getting a preview here, so I want to click on this option, and again all of these various options are pictured clearly in the PDF document. So if you are confused at any point, if you just really study the screenshots, you will see certain options are ticked or switched on. So it's this option here. Then I get a preview of sorts of how thick the rib will be, and we want to put some draft angle on this rib for all the reasons that we've talked about draft angles on everything else. So I'm putting 2 degrees of draft on there, and then I'm happy with that rib feature. So you can see the draft angle from this perspective. There are the faces of the rib angled out at 2 degrees. The rib feature has taken the sketch that I initially created and it's projected it outwards in this direction until it reaches the inner face of the part. But also it's projected it downwards in this direction until it reaches the inner face of the part. So it's important that the sketches that you create your rib sketch on, or the planes, sorry, that you create your rib sketch on, are either in line with the top of the part, or, as we've done here, down inside the part by some distance. If they are up above the part, they will fail. The system can't create a rib unless at some point away from the rib it encounters the inner face of the part somewhere. So Now let's create a pattern of these ribs. So I'd like a copy of this rib every so often along this part, but I'd like those copies to be able to adapt to the fact that the part gets thicker and then thinner and then thicker again and then thinner again. So we can do that, and we're going to use the curve driven pattern. So select curve driven pattern. We need to give it a direction, so this will be a curve in our case. So I'm going to pick that curved edge of the top of my part as a curve, and then I'll just get the number of pattern members from the PDF. So it's 8 pattern members that we want. So the number of pattern members includes the original copy of, in our case, the rib. So when I say 8 instances here, or 8 pattern members, I have to include the original as well. So I'll get 7 extra ribs as well as this original rib. The spacing that I want for these is 20 millimeters, and then down here this box which is glowing in blue, that is for me to select the feature that I want to pattern. So in this case I'm clicking on the rib. I'm not seeing a preview now, and I've noticed that the direction arrow is set in the wrong direction, so I'm going to click on it. Then I should see a preview. However, what's happening is the angle of my sketch line isn't varying as it gets copied. It's staying at that angle which is perpendicular to the edge down here. Now in my case I don't want that. I want the angle to vary. As the edge curves slightly up here, I want the new ribs to come out at perpendicular to this location. So the way that we achieve that is tangent to curve, like that. And you can see the angle of the ribs now varies as the curve curves round the corner. So this rib is almost vertical and this one has a discernible angle on it. So if you want that, you click on tangent to curve, and if you don't want it, you can align it to seed. So this is the seed copy, the original copy. So click on OK. We have our ribs. They're all adapting to the variety of widths that our part kind of transitions through because of those that grip shape. And then the last little bit of this particular section of the tutorial is just, we're going to do a simple extrude cut. So I'm going to create a sketch on the plane 3, so the plane that we created to sketch the rib shape on. So there it is, plane 3, sketch, and I'm just going to put a simple, well, let's do an offset here. So I'm going to use the offset tool, and I'm going to select that edge. In fact, let's say select chain, that edge, and let's start this again. Offset entities, the outer edge is probably a better idea. And then I want to reverse that, and I want to reduce that down to, just consulting the PDF again, 6 millimeters, like that. So we're taking a copy of that edge, but we're offsetting inwards by 6 millimeters. Then I'm going to do the same thing again. So offset entities, but this time I'm going to click on the offset line that I've created, like this. And I'm going to click on reverse, and I'm going to say 26 millimeters. Maybe a bit less, 24, something like that. Okay, so this top edge, or this top line, is related to that edge of the part. So if that edge of the part changes in curvature or anything about it, this line will change along with it. And then this line in the sketch is in turn related to that line. So if that line changes, this line will change. So that's a nice way to link sketches back to the geometry of the part itself. So now I'm going to get the line tool and I'm just going to close this shape up at either end. So there's that end closed and there's that end closed, and then I'm going to create a simple extrude cut down into the part slightly. So how deep are we taking this? 5mm down into the part. So this might be typical, and I'm going to put a draft angle on this as well. I might put quite a high draft angle on this one, 5 degrees, sorry. And that's essentially what we've created. So why might you do that? Well, often with injection molded parts such as this, there are other components within the case, which is essentially what we're making, that need to be accommodated. So in this case, if this was a tool handle, there might be a piece of steel that sits inside this handle, and this handle is just there to create a more comfortable surface for the end user to hold. So that might be there to accommodate the steel section of the tool as it passes through this handle. Other uses for this sort of feature, this kind of slight cutaway of ribs, you may have printed circuit board or other electronics components, and you can kind of accurately locate them within the main body if they drop down into these recesses. So it's quite a common method of creating these sorts of recesses in the ribs. So that's it, we've essentially finished our part there. We will continue this process further. We'll probably make some edits to this part. We'll place this part in a wider assembly, and we'll create some other parts using the surfaces and the sketches within this part as reference, so that all the parts fit together. They're all shaped similarly as they meet each other at either end or at the centre line.